Good morning, everyone. Thank you for joining us today. We're here to address a challenge that has been impacting our company's bottom line and our customer experience. As a mid sized retailer, we've been operating in a hybrid environment, physical stores combined with an online platform. Unfortunately, customers are faced repeated frustrations. Stock inconsistencies between what's online and what's actually available in stores, delayed order fulfillment, and a lack of personalized recommendations. The result: customer dissatisfaction, higher operational costs, and inefficiencies that threaten our competitive edge. Today, we're presenting a vision and solution that not only solves these problems, but also positions us for long term growth: a unified microservices based e commerce and inventory management system. Let's break down the pain points. Stock inconsistencies. Customers see products listed online, but when they arrive at the store, items are unavailable. This erodes trust. Delayed fulfillment. Orders take longer than promised because our systems don't update in real time across channels. And poor personalization. Our current systems don't leverage customer behaviors effectively to drive recommendations. All of these issues combine to impact our ability to deliver a seamless omnichannel experience. They increase costs, frustrate customers, and slow down our business operations. So, what do we need? We need a system that can synchronize data in real time, unify both online and offline operations, and harness analytics to better understand and serve our customers. The architecture we're proposing is microservice based, a modern approach where independent services handle distinct domains. Our user management service manages authentication, authorization, and profiles. Our inventory service manages real time stocks across warehouses and stores. Our payment services securely processes transactions. Our recommendation service leverages AI and customer history for personalization. And then finally, our analytics service provides insight into trends, sales, and customer behavior. All of these services connect through our API gateway, which routes requests from both web and mobile clients. The gateway adds load balancing and security layers, ensuring reliability and trustworthiness. Architecture sets the foundation for achieving scalability and resilience. Microservices are ideal here. They allow us to scale individual services independently, isolate failures, and quickly add or evolve features without disrupting the entire system. To make this vision tangible, let's look at the architecture from three perspectives. From a conceptual view, customers interact with digital channels, whether it be web or mobile, that connect on our unified backend. Orders, payments, and inventory checks flow seamlessly. Business managers access analytics dashboards to guide decisions. From a logical view, the system is broken into discrete microservices. Each service has its own responsibilities and communicates via APIs or messaging queues. For example, the inventory service notifies both the recommendation and analytics services whenever stock levels change. From a physical view, these services are deployed in the cloud, whether it's Amazon Web Services, AWS, or Azure. We'll use containers orchestrated by Kubernetes for resilience and scalability. This ensures our system is elastic, capable of handling high shopping traffic during peak events like Black Friday without downtime. The choice of languages, frameworks, and tools is critical. So here's our tech stack and design proposal. For our back end, we will be using Java with Spring Boot and Python with Django or Flask. Java offers reliability and enterprise scale support, while Python provides flexibility, especially for analytics and machine learning. For our front end, we propose React with TypeScript for modular, maintainable web applications. For mobile, we can go native with Kotlin or Swift or use React Native for cross platform efficiency. For our databases, PostgreSQL for transactional consistencies and MongoDB for unstructured product catalogs. And then finally, for our DevOps and deployments, Docker and Kubernetes for containerization, Jenkins for CI, CD pipelines, and then GitHub for version control and collaboration. Together, these technologies can give us developer productivity, reliability, and future scalability. To ensure our architecture is both flexible and maintainable, we will use these proven design patterns. Singleton, used in our central logging services, ensures consistent logging across microservices. For our observer, our inventory changes trigger updates in both recommendation and analytics services. This driven model keeps systems in sync. For our factory method, payments processing support multiple providers like PayPal and Stripe without hard coding. A factory generates the correct transaction object. For our adapters, for shipping integrations, we use adapters to unify multiple third party APIs under one interface. This avoids disruption to our core logic. And for our repository, this will separate data access from business logic, ensuring maintainability and cleaner code. These patterns reduce complexity, improve adaptability, and align with industry's best practices. Our design also embodies solid principles of object oriented design, which are key to long term sustainability. Our single responsibility is each microservice handles exactly one domain: user, inventory, payments, etc. For open and closed, modules like payment service can accept new providers without rewriting existing code. For Liskov substitution, derived payments classes like PayPal or Stripe can substitute for one another without breaking functionality. Our interface segregation services define small targeted interfaces so clients aren't forced to depend on unnecessary methods. And then finally, our dependency inversions. High level modules depend on abstractions, not concrete classes. Recommendations depend on data interfaces, not specific database code. So, together, these principles ensure the system is adaptable, maintainable, and ultimately future proof. So, now let's connect this back to our business outcomes. Our customer trust is real time synchronization ensures product availability is accurate. For faster fulfillment, orders are processed smoothly across channels. For our personalized experiences, recommendations drive increased sales and stronger customer loyalty. For operational efficiency, automation and integration reduces cost. And finally, for scalability and resilience, the system can handle seasonal spikes without service disruption. So ultimately, in short, this solution doesn't just solve our current challenges, it positions us for growth and competitiveness in the retail market. To summarize, we're addressing critical operational challenges with a microservice based architecture that ensures real time synchronization, personalization, and scalability. By applying proven design patterns and adhering to solid principles, we guarantee a system that's robust, maintainable, and aligned with business goals. The solution bridges the gap between online and offline retail, enhances customer satisfaction, and reduces operational inefficiencies. Thank you for your time. We look forward to discussing how we can move forward with this implementation and make this vision a reality.